All right, welcome back to The Explainer. Today we are diving deep into something you probably use every single day but have never seen, Kubernetes. It's kind of the secret architect holding the entire modern internet together.
I mean, seriously, have you ever just stopped and thought about that? You've got millions, maybe billions of people online right now, streaming movies, shopping, working, all at the same time. How does it not all just collapse into a giant digital heap? It feels like it should be absolute chaos, right? Well, it turns out there's a system, a really clever one, that brings order to all that chaos. And that's exactly what we're going to unpack today.
So here's our game plan. We'll start with the problem, what I'm calling the rise of digital chaos. Then we'll see how Kubernetes brings order to that chaos. We'll explore its structure, which is a lot like a digital city. Look at the buildings inside that city, we call those pods, how they talk to each other through the network, and finally, how you, the user, actually speak to Kubernetes using a blueprint.
Okay, first things first. To really get why Kubernetes is such a big deal, you have to understand the mess it was designed to clean up. We need to look at how things used to be, and honestly, how they were starting to get really, really complicated. So not too long ago, applications were these big monolithic things, one giant block of code. If you wanted to update one tiny feature, you had to redeploy the entire thing. It was slow and risky. So developers had this brilliant idea, microservices. They started breaking down those big apps into tiny, independent pieces. Think of it like building with Legos instead of carving from a single block of stone. It was a massive improvement, for sure.
And where do these little Lego bricks, these microservices, live? Well, they get packaged up into these neat little boxes called containers. Containers are super lightweight and efficient, which is awesome. But this created a whole new headache. Suddenly, instead of managing one big application, you're trying to juggle hundreds or even thousands of these tiny little boxes.
And trying to manage all of that by hand? Forget about it. It's just impossible. Imagine you're a conductor for an orchestra with 1,000 musicians, but they're all playing from different sheets of music, and some of them just wander off stage whenever they feel like it. That's not a symphony, right? That is pure, unadulterated chaos. And that's the problem we were facing. So, out of this chaos came the need for a conductor, a digital conductor, something that could take that 1,000-piece orchestra and get everyone playing in perfect harmony automatically. We needed an orchestrator. And that's what container orchestration is all about. It's the automation of everything, deploying the containers, scaling them up when traffic gets heavy, connecting them to each other, basically managing their entire life, from birth to death. It's the process of turning that messy, chaotic orchestra into a finely tuned, well-oiled machine. And Kubernetes? Well, it's the most famous conductor in the world for this job.
So what does all this automation actually get you? Well, it boils down to these three promises. First, high availability. That means your app stays online, period. No more dreaded downtime. Second, scalability. You get a huge spike in traffic? No problem. The system just adds more resources to handle it. And third, disaster recovery. If something literally catches fire in a data center, the system can recover and keep your application running. This is the magic of orchestration.
Okay, so how does Kubernetes actually pull this off? The best way to wrap your head around it is to use an analogy. I want you to picture Kubernetes not as a piece of software, but as a living, breathing, self-managing digital city. And in the Kubernetes world, we call this city a cluster.
Now, any city has two main parts, right? You've got the leadership, city hall, the decision makers, and then you've got the rest of the city, where all the work actually gets done. In our Kubernetes city, it's the same. We have the master node, that's the brain. It's the control tower calling all the shots. And then you have the worker nodes. They're the brawn, the districts, and neighborhoods where all the applications are actually running.
So let's peek inside that control tower, inside the master node. There are a few key players in there. The API server is basically the front door, or the main switchboard. It's how you talk to the city. Then there's the scheduler. Think of this as the city planner who looks at a new business, a new application, and decides which district or which worker node it should be built in. The controller manager is like the city's maintenance crew. It's always watching, and if it sees a building crumble, it automatically sends a crew to rebuild it. And finally, you have etcd. This is the official city records office. It holds the single official truth about everything happening in the entire city. All right, so we've seen the city from a bird's eye view. Now let's zoom right down to the street level, into those worker districts, and look at the actual buildings where our apps live.
So here's a key thing about Kubernetes. You don't work directly with those containers we talked about earlier. Instead, they live inside something called a pod. A pod is the absolute smallest, most fundamental building block in our digital city.
It's like a tiny, self-contained apartment that holds one or more containers that need to work closely together.
Okay, and this next part is maybe the most important concept in all of Kubernetes. You have to get this. Pods are ephemeral. That's a fancy word that means they are temporary. They are designed to be disposable. Think of them like cattle, not pets. You don't get attached to them. They can and will disappear at any moment. And this isn't a bug, it's the central design feature that makes the whole system so incredibly resilient. But wait a second. If the buildings in our city are designed to be torn down and rebuilt constantly, that creates a pretty big problem, right? How do you find anything? How do you send mail to an address that might not exist in 5 minutes?
Let's get specific. Every single time a new pod is created to replace an old one, it gets a brand new unique IP address. That's its digital address. So if you have one part of your application trying to talk to another part, like a database, and that database pod suddenly dies, its replacement is going to have a totally different address. How is anything supposed to find it? It's a huge logistical nightmare.
And the elegant solution to this nightmare is something called a service. A Kubernetes service is like a permanent, unchanging postal address. The building behind the address can be torn down and rebuilt 100 times, but the address itself, 123 Main Street, never, ever changes. It gives you a single, stable point of contact that you can always rely on.
And this service is a real multitasker. It has two incredibly important jobs. Job number one, give you that permanent, stable IP address so other apps always know where to send their messages. But job number two is just as cool. If you have, say, 3 identical copies of a pod to handle a lot of visitors, the service acts like a smart traffic cop. It's a load balancer. It takes all the incoming requests and distributes them evenly across all the pods, so no single one gets overwhelmed. Pretty clever, huh? Okay, so we've got our city with its master and worker nodes. We've got our disposable buildings called pods, and we have our permanent street addresses called services. We have all the pieces, but how do we, the city architects, actually tell Kubernetes what to build? How do we hand it the blueprints?
This is the last big idea, and it's a fundamental shift from how we used to do things. With Kubernetes, you don't boss it around. You don't give it a step-by-step list of commands like, do this, then do that. No. Instead, you just describe what you want the final city to look like. You give it a blueprint, a declaration of your desired end state, and you let Kubernetes figure out how to get there. So the process looks like this. First, you write a simple file that says, hey, Kubernetes, this is my goal. I want 3 copies of my web server running at all times. That's it. That's your blueprint. Second, Kubernetes takes that blueprint and does all the hard work. It schedules the pods, assigns them to nodes, and gets everything running. But here's the real magic, the third step. Kubernetes maintains that state. It's constantly comparing your blueprint to the real world. If a pod crashes and now there are only 2, the controller manager goes, whoa, that's not right, and automatically creates a new one to get back to your goal of 3. It's a self-healing system.
So when you zoom all the way out, what you see is that the foundation of the modern cloud, the thing that makes it all possible, isn't just clever code. It's order. Kubernetes is this incredible system designed to take the natural chaos of thousands of moving parts and orchestrate it into a resilient, self-healing, and predictable system. And the upshot of all this? It frees up human beings, the developers, to stop worrying about all that complex plumbing and just focus on building the next amazing app that we're all going to use. And that, right there, is why it has completely changed the game.